The science of chromatography and color analysis. Title: The science of chromatography and color analysis. Introduction. Color is a fundamental aspect of our daily lives, affecting our perceptions and emotions. Whether in art, design, or science, the ability to analyze and understand colors is crucial. One powerful technique that plays a significant role in color analysis is chromatography. In this article, we delve into the science behind chromatography, its applications in color analysis, and its impact on various fields. Understanding chromatography. Chromatography is a technique used to separate and analyze mixtures by exploiting the differences in their interactions with a stationary phase and a mobile phase. The stationary phase is typically a solid material or a liquid-coated solid, while the mobile phase is a liquid or gas that carries the mixture through the stationary phase. As the mixture migrates through the stationary phase, it separates into its individual components based on their affinities for the stationary and mobile phases. Types of chromatography. There are several chromatographic techniques employed in color analysis, each with its own unique advantages and applications. 1. Thin layer chromatography, TLC. In TLC, a thin layer of stationary phase is coated on a solid support, such as glass or plastic. The sample mixture is applied near one end of the plate, and the plate is then placed in a container with a suitable mobile phase. As the mobile phase moves up the plate, it carries the components of the mixture at different rates based on their affinities for the stationary phase. By comparing the migration distances of known reference dyes, unidentified dyes can be identified. 2. High-performance liquid chromatography, HPLC. HPLC utilizes a liquid mobile phase and a high-pressure pump to force the sample through a column packed with a stationary phase. This technique is highly efficient and widely used for separating and analyzing complex mixtures. In color analysis, HPLC enables the identification and quantification of colorants, dyes, and pigments present in a sample. 3. Gas chromatography, GC. GC separates volatile compounds based on their affinity for a stationary liquid or solid phase and the vapor pressure of the sample components. While GC is mainly used for analyzing colorless compounds, it can also be used to separate and analyze volatile colorants. This technique is particularly useful in forensic color analysis and the identification of ink and paint. T constituents. Applications in color analysis. Chromatography finds extensive application in various fields related to color analysis. 1. Forensic science. Chromatographic techniques play a vital role in forensic color analysis. 2. Quality control in industries. Chromatography is widely employed in industries involved in the production of dyes, pigments, paints, and other colored materials. By ensuring the quality and consistency of colorants used in manufacturing processes, chromatography helps maintain product standards and consumer satisfaction. 3. Art conservation. Chromatographic techniques assist in preserving and restoring artworks. 4. Pharmaceutical analysis. Chromatography is an essential tool in pharmaceutical analysis, particularly in the identification and quantification of colored impurities in drug formulations. This ensue Re's the safety and efficacy of pharmaceutical products, upholding regulatory standards. Advancements in chromatography techniques. As technology progresses, chromatography techniques have also evolved to provide enhanced performance and sensitivity. These advancements enable the identification and quantification of minute quantities of colorants and help detect and characterize new classes of compounds. Chromatography is a powerful technique used in color analysis that separates and analyzes mixtures based on their interactions with the stationary and mobile phase. TLC involves applying a sample mixture to a solid support coated with a stationary phase and observing the migration of the components as the mobile phase moves up the plate. HPLC utilizes a liquid oval phase and a high-pressure pump to force the sample through a column packed with a stationary phase, making it efficient for complex mixtures. GC separates volatile compounds based on their affinity for a stationary phase and vapor pressure. Chromatography has broad applications in color analysis. In forensic science, it aids in identifying dyes and pigments in fibers, paints, and inks, providing evidence in criminal investigations. Industries use chromatography for quality control, ensuring consistent colorants in manufacturing processes. Art conservation benefits from chromatographic analysis of historical paintings to develop appropriate conservation strategies. Pharmaceutical analysis employs chromatography to identify and quantify colored impurities in drug formulations, upholding regulatory standards. Advancements in chromatography techniques, such as mass spectrometry and UV vis absorbance detectors, have improved the accuracy and selectivity of analyses. Mass spectrometry enables the identification ion and quantification of minute quantities of colorants. UV vis absorbance and fluorescence detectors enhance the detection and characterization of new compounds. Chromatography is a powerful technique in color analysis that utilizes the differences in interactions between a stationary and mobile phase to separate and analyze mixtures. TLC involves applying a mixture to a solid support coated with a stationary phase and observing the migration of components as a mobile phase moves up the plate. HPLC uses a liquid mobile phase and high pressure pump to force the sample through a column packed with a stationary phase, making it efficient for complex mixtures. GC separates volatile compounds based on their affinity for a stationary phase and vapor pressure. Chromatography has various applications in color analysis. In forensic science, it aids in identifying dyes and pigments in fibers, paints, and inks, providing evidence in criminal investigations. Industries use chromatography for quality control, ensuring consistent colorants in manufacturing processes. Art conservation benefits from chromatographic analysis of historical paintings to develop appropriate conservation strategies. Pharmaceutical analysis employs chromatography to identify and quantify colored impurities in drug formulations, upholding regulatory standards. Advancements in chromatography techniques, such as mass spectrometry and UV vis absorbance detectors, have improved the accuracy and selectivity of analyses. Chromatography is a powerful technique used in color analysis to separate and analyze mixtures. It works by exploiting the differences in interactions between a stationary phase and a mobile phase. His stationary phase can be a solid material or a liquid-coated solid, while the mobile phase is typically a liquid or gas. There are various types of chromatography techniques employed in color analysis. These include thin-layer chromatography, TLC, high-performance liquid chromatography, HPLC, and gas chromatography. GC. TLC involves applying a sample mixture to a thin layer of stationary phase coated on a solid support. As the mobile phase moves up the plate, it carries the components of the mixture at different RAT s based on their affinity for the stationary phase. This allows for the identification of unknown dyes by comparing their migration distances with those of known reference dyes. HPLC utilizes a liquid mobile phase and a high-pressure pump to force the sample through a column packed with a stationary phase. It is highly efficient and widely used for separating and analyzing C. Complex mixtures. In color analysis, HPLC is used to identify and quantify colorants, dyes, and pigments present in a sample. GC, on the other hand, separates volatile compounds based on their affinity for a stationary liquid or solid phase and the vapor pressure of the sample components. It is mainly used for analyzing col or less compounds but can also be used to separate and analyze volatile colorants. GC is particularly useful in forensic color analysis and the identification of ink and paint constituents. Chromatography finds extensive application in various fields related to color analysis. In forensic science, chromatographic techniques play a vital role in identifying dyes and pigments found in FIB.